Glue is an interesting substance. It has been used for a long time to chemically bind substances together. One of the earliest known uses of glue was over 200,000 years ago in a primitive cutting instrument in Italy. From then, glue has developed enormously, from the first superglue in 1956 to the glues used today in your home. However, glue is also used for more dubious purposes. Many youth today have reported their classroom chair to be slightly adhesive, leading to some experts to declare a chair gluing pandemic as the greatest problem for world peace. We certainly do not want to be in that sticky situation. But this problem is not as severe as possible. The reprobates are underinformed, and without science as our ally. We made glue from milk, and will compare it to two other student glues, to see which one works best, to see, that is to say, which one holds the most weight. This is a video of how we made the milk. Here we are, making glue. The thing is, what's actually happening? Ooh. Alright. First, you add the milk. Then you add the vinegar. I know what I'm doing. Well, that was anticlimactic. Oh yeah, don't tell me that's something. Ready? Yeah. How much do we heat it? Until clumps form. So now we heat until clumps form. Want to change the flame? Yeah. Maybe not. Why not? Why actually?
What you got in the egg?
Milk and vinegar.
And what are you doing?
We're making glue. Now, as you can see, clearly time has passed, but we decided not to show that. We have cooled the milk and vinegar mixture so much that solid milk curds have begun to form. I would not want this on my cereal. Now we shall transfer it and drain it. How interesting. There are two main types of glue. One of these is called an interlock glue. An interlock glue works by seeping into little niches within the substance and bonding cohesively in place. The glue, now solid, is very reluctant to leave these formations, and a lot of energy needs to be applied to melt the glue or to snap it in half. The glue formations are now hardened in gaps to the bound substance structure, binding them to the glue and subsequently to each other. It is that simple. The other type of glues are called chemical glues. They adhere to incompatible substances in multiple ways. The first way is with dispersion force bonding. If the glue is spread over the surface of the substance, the glue molecules and substance surface molecules will bond with intermolecular dispersion force bonding. The second way, the sheer amount of bonds makes this adhesion feasible. However, because dispersion force bonding is relatively weak, this glue is relatively easy to break. The second way is with chemical bonding. If the substances and the adhesive both have polar components, the polar components and the glue and substances can bond, creating strong chemical bonds, as the two substances would not form polar-polar bonds on their own, considering they may not have polar bonds to start with. Chemical adhesive is essential for this process. The glue we made in the above segment is a chemical glue, although most glues bond with a combination of the interlock and chemical processes. Now it is time for an experiment. With our chemical milk glue, our standard glue stick glue, and our clag glue, which is I think it's a combination, but combination glue, we shall now test their strength by suspending weights from them and seeing which one can hold the most weight before the weight pulls the two blocks apart. As you can see here, we have two wooden blocks binded by one of the three glues. We've inserted eye hooks into the bottom of one of the blocks, and we shall suspend them from these retort stands. We shall then, using these holders, suspend weights from the bottom of the eye hooks like such. Now, each holder weighs 50 grams, and these weights also each weigh 50 grams, so we shall see which one holds the most weight before it snaps. Okay, let's start with the glue stick glue. This is zoomed in on. What a surprise, it's holding 50 grams. Let's continue to add weights. 100 grams. 150 grams. $1,600 grams. $1,650 grams. $1,700 grams. Due to time constraints, we'll move on. Now it is time to test the last glue, the clag. We'll start again with 50 grams. 100 grams. 150 grams. 200 grams. $1,700 grams. It is now suspended all the weight we have at the moment. I think it's time to get a bigger weight. And now we are back at the experiment zone with larger weights. Unfortunately, we were suspending them from the first clay block and it snapped, but we were unable to capture this moment on film. It snapped at 2.5 kilograms. Now we shall experiment on the second one. This hook which holds the weights weighs a half kilogram, and these blue weights here weigh a kilogram each. Let's see how long it is before the cohesive forces falter. Half a kilogram. No surprises there, as this block did hold 700 grams before. Well, 1.5 kilograms. A slight blip in the proceedings, but otherwise insignificant. Two and a half kilograms. You hold the torch down, or you can add some more. 3.5 kilograms. As shown in the experiment, the strongest glue was the clag, a chemical glue having held 3.5 kilograms of weight. This was presumably the case because the main component of clag is water and starch, leading to a lot of polar bonds forming and hence strong adhesion. The glue stick, whilst holding 1.7 kilograms, broke away at the slightest touch. After testing, when we removed it from the retort stand, the glue stick is also water-based, with its active ingredients composed of plant matter. Presumably it bonded through a combination of dispersion forces and mechanical adhesion, or interlocking, and cohesion was maintained through polar bonding, which would explain why it was strong but brittle. It snapped when the interlock bonds broke, and the polar bonds broke. The polar bonds responsible for the cohesion broke, and then they were insufficient to maintain the cohesion and adhesion because they were destroyed, really. The chemical milk glue broke at the slightest touch, without any weight suspended from the wooden block. Perhaps the freezing and liquefying had an effect on the structure, or it simply had very weak cohesive properties. Perhaps the addition of more water diluted the active ingredient, the collagen in the milk, and subsequently it was not very strong. We are not sure. A disappointment. So, if you are going to glue wood together and have only these three adhesives available, use the clag. Use this on wooden chairs and you will be sure to gain adherence.
Involved made from their own